Hi guys. So last time we learned about section 1.4. Let me review a little bit about 1.4. Okay. So we learned about 5 concepts in there. The very first concept is about a function, and the definition, it tells you that for one x value you can get only one and exactly one y value. Okay. If for one x value you get more than one y value, then it's not a function. Okay, and there in the first objective of 1.4, I also told you guys about a concept of the domain range. The domain in here is the set of all values of x, and the range in here is the set of all y values. Okay, and the next concept after that is the graph of a function. If you have a graph of a function, it helps us to know whether like an equation is a function or no by using the vertical line test. Okay, so just imagine if you're like holding your pen or a pencil vertically across your graph from left to right. If at all time your pen hits the graph only one time, then the graph tells you that this equation is a function, else that equation is not a function at all. For example, if you have like, I don't know, a function that looks like this is the graph of a function. Okay, and just imagine your pencil like this, like you hold it vertically. Okay, this is not a vertical pencil. There we go. Okay, if you hold your pencil or your pen vertically across the graph from left to right, originally it doesn't even touch the graph, right? And say at this moment it touched the graph only once at here, so it could be a function, right? But at the next second it touches the graph here and here 2 times. 2 is more than 1, right? So this is not a function. So let me write function and then just cross it out to tell you that this is a non-example of a function. Okay, and the tool, the vertical line that I just told you guys, is called a vertical line test. Okay, and it helps us to define whether an equation is a function or no. Okay, and we'll also talk about the function value in a sense that if I give you something like, I don't know, f of x equals to say x plus 1 in here, and if I ask you what is the function value when x equal to say -4, then you're going to plug -4 into x right here to get -4 plus 1, which is -3, and you're going to tell me that f of -4 equals to -3. This is the function value, okay, or the y value, if you want to refer it that way, as cool too. And in this page, I also told you about the concept of one-to-one function. Let me get some of these out of the paper first. One-to-one function is only applied for functions, right? Because we know that the equation is already a function, and then we apply the horizontal line test for the graph of that function. For example, if you have a graph, I don't know, looks like this, for example. Okay, and just imagine you hold your pencil again, but this time you hold it horizontally and you move it across the paper from like the bottom up top. So at the beginning, your pencil is right here, right? It has no contact whatsoever with the graph, with the red line there. But then in the next moment, it touches the graph once, right there. So it could be a one-to-one function. But wait, the next second, when you move it a little bit up more, it touches your graph twice, right? Like there and there. So this is not one-to-one function. It's a function, but it just doesn't have the property of one-to-one, okay? And the tool that we use in here is called the horizontal line test, okay? So again, the vertical line test, it tells you whether an equation is a function or no. The horizontal line test, it tells you that a function is one-to-one or no, okay? And then the next concept that we learn in 1.4 is about combinations of functions, is composite functions. So technically, let me give you an example. If my last example are too hard for you guys. So for example, if I have something like f of x equal to, I don't know, square of x, and then g of x equal to, say, x minus 3 in there. If I ask you to find f of g of x, then your job is to plug in g into f, okay? So I'm gonna take this equation here and I stuff it in for x of f. So I start with a function of f, which is the square root, but then in place of x, I'm not gonna write x, I'm gonna write the whole function of g, which is x minus 3, okay? And if I ever ask you to find g of f of x, then it tells you to plug in f for g, okay? So let me take this arrow out, take the circle out, and this time we're gonna plug in f. We're gonna take this whole function of f and circle it, and then we plug it to g. So whatever you have x for g, you plug f in, okay? So the function of g is start with x minus 3, but in place of x, I'm not gonna write x yet. I'm gonna write minus 3 because the minus 3, it doesn't even have the x, right? And in place of x, I'm gonna write the f function, which is square root of x, okay? So if you look at these, it tells you that f of g of x is different than g of f of x, right? As you can see, this square root up here, it lasts all the way to -3, while the square root on the bottom, it only stops for x, right? So it only means for x. So these two are different from each other. These are not the same thing. So if I ever ask you something like, is f of g of x the same thing as g of f of x in a test, for example, make sure you say no, okay? Because they're not the same thing. Even though they have like similar looking to each other, they're not the same thing at all, okay? And the very last concept that we learned from 1.4 was about an inverse function, okay? In the sense that if you want to solve for an inverse function, first of all, you have to swap, you have to replace f of x with y, and after that you interchange x and y, and lastly you solve for y. What do I mean by that? For example, if I give you a function, say y equals to, I don't know, x squared plus 1 maybe, okay? And if I ask you to find the inverse function of this one, first of all, well, because we don't even have f of x, right? So we don't even have to replace f of x with y anymore because we already had the y. So next step in here, we're gonna interchange x and y. So in here, I start with x, and this one in here will be y. Plus 1 is just plus 1. And after that, lastly, I'm gonna try to solve for y. So I'm gonna minus 1 from both sides. And I'm gonna get y squared equals to x minus 1. Lastly, I take the square root of both sides to isolate my y. And I get y equals to plus and minus just because of that 2 right there. And I have x minus 1 in there. And now you're gonna ask me, well, what is the answer for this one? Because like for inverse function, I usually just have one function. But in here, it implies that I have two functions. The first one is positive square root of x minus 1, and the second one is negative square root of x minus 1. So which one of these is a function of this original function right there? And I'm gonna tell you with no restriction, none of these are the inverse function, because this one function right there, it doesn't even have a function. It doesn't even have an inverse function, okay? Why? Because if it has more than one inverse function, we say that it doesn't have the function. It doesn't have the inverse function, sorry. Okay, but if I make some restriction, if I give you something like, from the problem, x has to be from, you know, like, greater than 1, for example, then this one in here would be the function that you're talking about, okay? And if I give you something different every time, like you have to base it out on the main to find whether the first one or the second one is the inverse function of the given function or no. And if it doesn't say anything about the restriction, just say no, there's no inverse function, okay? So it could be tricky sometime like this in the test, okay? So make sure you watch out for those like curveballs, okay? And then let me take those out. All right, let's talk about 4.1. All right, 4.1 is about exponential functions. Well, it's actually about exponential and logarithmic function, but let's just focus on 4.1 right now, which is about exponential function. So if you remember back in the day, and if you have your calculator with you right now, if you look over it really quick, you will see the symbol E, right? Wait, okay. E for exponential. That's the shortcut. Okay, and I'm going to explain more about the definition of exponential functions, okay? So let's review some old concepts first. We are already familiar with the behavior of algebraic functions, such as polynomial. I mean, like, in here, what I mean by that is like linear equation. You know, we have like a line, could be increasing, it could be decreasing, it could be flat, it could be vertical, okay? We have like 4 cases for a line, right? And we also have quadratic in polynomial. Quadratic, let me just shortcut quad. It could be a U shape or it could be a upside down U shape, okay? And rational function, we're gonna talk more about it, but if you remember back in the day, the rational function, it just means something like has a fraction, for example, like 1 over x, okay? Or like x over like square root of x squared or something like that. As long as it has like a fraction and it has some variable on top, variable on the bottom of the fraction, is a rational function, okay? And radical function, radical in here, it means like square root function, okay? If you remember back from the parent functions page, the square root function, it looks like an arc like this. But if you don't remember it, it's fine, okay? By interchanging roles and raising a constant to a variable power, you obtain another important class of functions called exponential functions. So notice that like an informal definition for exponential function, it tells us that for the power we're gonna have like a variable, okay? What do I mean by a variable power? So we know about, so in the past we talk about like 2 squared, we have like 4, right? This 2 in here we call it the base, and the little 2 on top of it we call it the exponent, okay? Another example is like if you do 5 to the negative, I don't know, 3, this 5 in here is the base. Okay, my tip in here is like the big numbers for the base, you know, like b and b, base and big number, and the small number in here is for the exponent, okay? All right, so the exponent in here, for these example, this one and this one, we have number exponent, right? But for exponential function, we have variable exponent. And by the way, power and exponent, they mean the same thing, at least for now, okay? So let's kind of like identify which of the following functions are exponential functions, okay? Let me put the answers in blue. Okay, the very first one, what do you think? 3 to the x, is it an exponential function or no? Well, let's look at the power of it. What is the power of this function right here? It's x, right? Which is a variable. So that's good. That means this one is the correct answer. It's one of the exponential functions in there. All right, let's talk about b. We have like x to the 4th power, and if you look at this power right here, the power of it is 4, right? Which is not like a variable. So it tells you that like this part of the equation in there is not exponential function. And if you look at this variable in here also, the power of it is like 3 over 2. Why? Because we have the square root. And I'm going to tell you guys how to know that it's a fraction of 3 over 2 in later sections. But for now, since we don't have like we don't have variable exponent, we don't have variable power, this is not like a good example of exponential function, okay? So let me take out a circle before you guys mistake that this is the answer. Okay, let's talk about C. C in here, what do you guys think? Does it have any like variable exponent? The answer in here is no, because it doesn't even have an exponent, right? If you want to think of it, it does have the exponent of 1. It is 1 to the 1st power. Let me put it in red. So this is like 1 to the 1st power, because like if you have 1 copy of 1, it means 1, right? But then again, since this number in here is a number, it's not a variable, so then C is not a good example of exponential function. Let's talk about D. D, which one in here is the base and which one in here is the exponent? Well, whatever number that you have like underneath of the x in here, this is the base. Just like the 5 in here in the second example, or the 2 in here in the very first example that we talked about, okay? And this little x in here, because it's written in like smaller size, this is the exponent, right? And because we have a variable exponent, this is also an exponential function. So far we have 2 answers, right? We have A and D. Both of them are exponential functions, okay? Let's talk about E. 5 in here is not a variable. 4 over 3 in here is not a variable. X in here, it has the power of 1, and 1 is not a variable. So E is not an exponential function, okay? For F, similar things. we have 2 in here, but again 2 is a number exponent, right? It's not like a variable exponent, so f is not an exponential function. For g, if you look at 4 and 5, well, 4 doesn't even have an exponent, but if you look at 5, it has an exponent of x, right? Which is good enough. So for g, it's also a good example of exponential function. Okay, and for age, we have x, but again, x in here is not an exponent. How do I know it? Because the x in here is written in like regular font. It's not in smaller size, right, compared to like other exponent. So h is not an exponential function. For I, we have an x in here. It is smaller in size compared to like -2, so you know for a fact that x in here is an exponent, and hence this one is a good example of exponential function. Lastly, we have 2.5 to the negative x. Well, some of you guys may ask me, now we have a negative. What does it mean? Well, it still doesn't like change the position of x, right? X is still hanging there in smaller size as an exponent, right? So this is also a good example of exponential function. So for more information, if you have something like, I don't know, -2 to the 2x, again, the x in here is hanging in the middle of like the air. The x in here is the variable and it's on the exponent, so this is also a good example of exponential function, okay? So if you just have x in there and the exponent is a good example of exponential function. If you have 2x, if you have 3x, if you have -x, anything in front of x in smaller font in like that position of the exponent is also a good example of exponential function, okay? So just recap for this like question in here. We have A, D, G, I, and J as the correct answers, okay? So now, as for like recap of the definition of exponential function, if A is greater than 0 and A is not 1, then the exponential function with base A is given by the form f of x equal to A to the x power, okay? So just like what I told you earlier in the examples, whatever in bigger size is the base, and whatever like variable in smaller font, in smaller size, on the top right, we call it the exponent, okay? And again, if you have, say, 2x squared here, x in here is the base, right? X in here, this is not like an exponent. So this is not a good example of an exponential function, but if you have 2 to the x, this is a good example of the exponential function because x in here is the exponent, okay? So watch out for the position of the x in there, okay? So in order to identify whether your equation or your function is exponential or no, look at the position of x, okay? And that's all you do, okay? Let's talk about the next objective of the day. We have exponential functions. Okay, so I have like a bunch of rules for you guys to remember. If you don't remember all of them, let's make sure that you have them down in the paper, or just, I don't know, like put it on the sticker notes or post-it, whatever you want to do with it. But make sure you have these formulas in front of you before the exam comes, okay? Alright, so we have 7 rules in here. Properties of exponents. Let A and B be positive numbers, okay? And what do I mean by positive number? They have to be bigger than 0. For example, like 2, 3, and 5, so on, right? So let me double check with you guys really quick. Is -5 a positive number or no? I hope everyone will say no because -5 is a negative number. But if you have any question on that one, please let me know, okay? Alright, let's talk about the very first rule in here, the very first property of exponents. A to the 0 equals to 1. Okay, so anything to the power of 0 equals to 1, okay? So if I have 2 to the 0, this is 1. A to the 0, this is 1. I don't know, like F and G, both to the 0, this is also 1, okay? Like anything, even like negative numbers to the 0, they all equal to 1, okay? Regardless of what base you have. As long as your exponent is 0, the answer has to be 1, okay? Okay, number 2, if we have like 2 terms in there, the first term is a to the x and the second term is a to the y, and we multiply them. If you see no operation between 2 terms, it means multiplication, right? So then you multiply them. What do we do in here? Because they have the same base, so we're gonna add up the top. We're gonna add up the exponents of each other. So at the beginning, we have like 2 a's in here, 1a and 2a, and now we combine them to get just 1a for the base. But for the exponent, at the beginning, they separately, right? Like the first one is x and the second one is y. But after you combine them, it becomes x plus y, okay? Similarly, if you have division, if you have a to the x divided by a to the y, we have subtraction, okay? So if you have multiplication, you have addition for exponent. And if you have division at the beginning, you have subtraction in terms of exponents, okay? I'm gonna talk more about like how to do them in these examples, but for now, just keep in mind that there are rules like that, okay? And for number 4, if we have a to the x to the y, then what does it mean? It means that you're gonna have one base, x, but how can you combine the 2 powers? How can we combine the 2 exponents in here? Well, we're gonna multiply them, okay? So notice that 2 is different than 4, okay? It's like way different than 4, but a lot of people tend to make the same mistake. People think that this is the same thing as this one, but no. For 2 on the left hand side, we start with 2 bases, right? And then we end up with 1 base. But then addition. For 4 on the left hand side, we only have 1 base, okay? So in here we have like 2 bases, and in here we have just 1 base, okay? For 2 bases, we're gonna have addition. For 1 base, we're gonna have multiplication. So make sure you can tell the difference between 2 and 4, okay? Don't mistake them, okay? For number 5, now just imagine if we have like 2 different bases, a and b, they are different from each other. They share the same exponent of x, then, well, you can distribute it out, right? Like if you break out the parentheses, just imagine that you can distribute the x for a and distribute the x for b. So you end up having a to the x and b to the x, okay? Similarly, if you have a divided by b and both of them having the same exponent of x, you can just distribute x into a and x into b to get a to the x over b to the x. Lastly, this is the very common use rule in here, and it's very important in the sense that you have to remember the negative power. There's a thing called negative power, okay, and it's useful. And in fact, we can convert from negative power to positive power. And in the test, make sure you write all the answers in positive power. So if I see something like 2 to the negative 1, this is not a good answer to me. If you give me something like a to the, I don't know, negative 3, this is also not a good answer to me, okay? How can we convert from negative power to positive power? First of all, we flip it, okay? So this, if we flip it, it becomes 1 divided by a to the minus x. So first step, we just flip it, right? Like completely flip it. So we have the extra 1 on the top, we have the fraction, and we write on the bottom. Nothing changes, right? Second step, take out the negative. So this is gone, okay? So we're gonna end up having 1 to the a to the x, okay? 1 over a to the x, okay? Make sure there's 2 steps to it. First step, flip it, put a 1 on top of it. Step 2, take out a negative, okay? And as you can see, this power in here, this x in here, is free from negative, right? So that's how we change from negative exponent to positive exponent. So with that saying, so if you have something like 2 to the negative 1 on a test, make sure you flip it at the beginning like this, and then take out a negative, okay? And for the second example, if you have a to the negative 3 on a test, make sure you flip it like this, and after that, take out a negative. Bam, okay? And now everything is correct. All right, let me talk more about like more examples in here. Okay, I know that there's a lot of like things in there, and you know, it requires a lot of work, but don't freak out, okay? Like most of these can be done by calculator, but make sure you show some work, right? Like you cannot just like plug everything into the calculator and give me the final answer, because that's not your work, that's the calculator work, okay? For example, okay, let's talk about example 1. Simplify each expression using the properties of exponents. So let me get rid of all the things that I write in here first, because I cannot see like the rules in here. Okay, that's better. All right, so first one, 5 to the second power times 5 to the third power. So at first glance in here, from 1 to 7, how many things in here have like 2 bases, right? Like 2 same bases. The only thing that I have that have the same basis as A and A is 2 and 3, right? You have 2 bases and both of them are the same, which is A and A. So for part A, I'm gonna go with 2 because I have multiplication. If you want to go with 3, it has to be something like division. Something like, I don't remember if I have it in here, but yeah, you will know when it comes to it. Oh, here we go. So this one is for 3, just a heads up. Why? Because we have like two bases. For part B in here, the bases are 2. They're the same to each other, but then you have like a different exponent on the top and you have like a different exponent on the bottom of the fraction. Okay, so for my example, to show some work, first of all, I'm gonna do 5 to the 2 plus 3, which is 5 to the 5th power, and if you put this one to the calculator, you will get 3125. Okay, so in the test, I know that we're not like elementary school anymore, so if you don't want to, you don't have to show me this step, but make sure you show this step. Do not show me just the answer, okay? Because that's a calculator work. I know the answer already by plugging everything into the calculator, but I need your work. This is the work, okay? For part B, we're gonna use number 4. Okay, so let me just write out like the property that I use in here, just as like a reference, just in case you guys want to like look back at these. So for part A, I use property 2. This doesn't even let me. Okay, there we go. And for part B, I use property 4. And my work for part B would be 5 to the 2 times 3, which is 5 to the 6th power. And this is 15,625 if you input it into the calculator, okay? So again, if you don't want to show this step, you can just show me that it equals to 5 to the 6th power. That's enough of the work to me, and you can show me the final answer, okay? Let me get rid of these. Oh, actually, I can keep writing on. Okay, for part C, this one to me is the easiest one because, well, first of all, by PEMDAS, we all know that you can do the things in the parentheses first, right? So then we're gonna do 5 times 2, which is 10, and it's to the 3rd power. So if you input it into the calculator, it has 1,000. Okay, but well, we learned about like the properties in here, so you might want to ask me which property of this is from the table, and I'm gonna tell you there's a second way to this one. So this is the first way, and the second way, the longer way, if you want to do it, let's go for number 5 in here. Let's go for property 5. So let me just try to write 5 in. Okay, there. And then I'm gonna have 5 to the 3rd power times 2 to the 3rd power, which is, what is 5 to the 3rd power? It is 125, and then times 2 to the 3rd power, which is 8, and then you're gonna end up having the same answer as 1,000. Okay, so this is one way to it, and this is the other way to it. Of course, if you don't want to do the second way because it's longer, I totally understand, that's fine. In the test, you don't have to do it both ways. You can just do one way, and that's cool to me, okay? And whichever way you do in here, as long as it makes sense to you, it should make sense to me, okay? So let me get rid of some of the words so I can have space to do part D. And again, if I talk too fast or if there's anything unclear on the lecture, let me know, okay? So let me put back the answer for C. The answer in here is 1,000. Okay, for part D, which is like the easiest one among like all the questions in this page, anything to the power of 0 is 1, so period, just 1. This one, it doesn't even have any work, okay? So as a reference to it, I'm gonna put like 1 in there for property 1. All right, the next one, 3 times 5 to the negative 2. So we have a problem in here because we have a negative in the power, right? The 3 in there doesn't even have any power, so leave it out of the game for now. Let's just leave 3 as 3. But for 5 to the negative 2, first of all, because it has a negative power, we want to make it positive power, okay? So what we're going to do, first of all, we're going to flip it by putting a 1 on top of it. Rewrite everything, and after that, take out a negative, okay? And after that, what do? We're going to multiply them straight across each other. 3 is actually 3 over 1, and please don't make a mistake of 3 being 3 over 3, because 3 over 3 is 1, not 3, okay? So watch out for that. Okay, so on the top we have 3 times 1, which is 3. On the bottom we have 1 times 5 squared, which is 25. So the answer in here is 3 over 25, okay? And the property that we use in here is 7 for like negative power. Okay, as for F, we also have a negative power, but as you can see, the 3 in here is a part of the base that is influenced under the power of negative 2. So we also use the property 7 in here, but let me put an error in here. Okay, so on the inside we're gonna have 15, right? Because 3 times 5, we have a 15 in there. And we have on the outside negative 2 because we don't touch on it yet. And then from here, first of all, we're gonna flip it, so we do 1 over 15 to the negative 2. But then I tell you guys to take out a negative because it's not meant to be there. We cannot have a negative after we try to convert from negative power to positive power, right? So the negative has to be gone. All right, and if you input this into the calculator, 15 squared, it is 225. And on the top part, we also have 1, right? So this is the answer for part F. Okay, as for G, let me put it in another color because it looks like a mess right now. Okay, G is also easy because it's just like D in a sense that anything to the power of 0 is 1. So the answer is 1, solid, right? No explanation. It's just because of the rule. Okay, and for H, okay, this is the case where you have to use 3. So let me put back red in here. So this is number 3. The way that you do it is that you're gonna do 5 because it's a base, and then the top exponent minus the bottom exponent, which is 3, and then 2 minus 3. Hopefully everyone get negative 1, not 1. If you don't know why, please ask me, okay? Like before the quiz on this week to clarify with you why 2 minus 3 is negative 1, not 1. Okay, and because we have a negative exponent, and like these example that I told you from the beginning, if you stop right there in the test, I'm gonna mark you off because I really hate exponent that are negative. Okay, so we're gonna use 7 in there, so let me put 3,7 in there to switch this negative exponent to a positive exponent. Okay, I'm actually doing it in a shortcut because at the beginning it has to be, okay, let me write in here. So we have 5 to the negative 1, right? If you flip it, it becomes 1 over 5 to the power of 1 because we take out a negative. And then because you only have like 1 copy of 1, right? So on the bottom, you only have 1 over 5. This is it, okay? So this is the answer for part H. And now let's talk about I. I is the same thing as part H. But if you notice, there's a change in the position of the exponent. On H, we have 2 on top and 3 on the bottom. But for I, we have 3 on top but 2 on the bottom, okay? So what happens in here? Let me put it in pink. We're going to have 5 as a base. And then we take the top exponent minus the bottom exponent. Okay, this is my subtraction side, okay? But it doesn't look like it. But, yeah. Sorry for the bad writing. So then we're gonna have 3 minus 2, which is 1 as the exponent, and as for the base we have 5, right? And because 1 copy of 5 is 5, 5 is the final answer for I, okay? And what is the difference between H and I? First of all, the difference in here is the position of the 2 exponents on top and bottom. Second of all, let me put it in blue. Okay, this one is negative exponent and this one is not negative exponent, right? So for this one you have to change it, but then this one you just have to like do it out and put it in the calculator to get the out answer, okay? And again, the rule that we use for I in here is 3. Okay? Alright, let me put back red. And then for J, let's look among like all the exponent properties in here. What do you guys think we're gonna use? Let's see. I'm gonna go with 6, right? Because it looks like the one that we have the most. So let's just put like 6 in here as a reference. Alright, so this one, you can just distribute the 3 inward. So then we're gonna get 5 to the 3rd power up top, and then 2 to the 3rd power in here. And then 5 to the 3rd power is 125 over 8. And this is it. Okay? Lastly, for K, another like easy peasy one, right? Because anything to the power of 0 is 1. And this is by the very first objective. Property. Okay? And as for your part, let me put a green star in here. So make sure you do everything from A to K, okay? Alright, let's talk about the next page. Okay, this one is not one of the objective of the day, but I just give it to you because this is like something some of you guys may have learned in the past. This is transformation of function graphs. It tells you how you do from the parent functions in order to get the new function, like whatever function that the problem gives you. And this table is really useful. I'm gonna tell you how to use this one while we're doing the next example. But just remember one thing, let me just briefly talk about it. If you have a negative in front of it, it means you reflect the function, the graph, over the x-axis. If you have a negative inside, it means that you reflect the graph over the y-axis, okay? If you have a number, if you're adding a number on the outside of a function, it means you're moving the graph upward, and negative for downward, okay? If you're adding a number on the inside of the function, it means you move leftward. If you subtract it, is rightward, okay? And lastly, if you multiply a number on the outside of a function, well, this case is a little bit complicated. If k is greater than 1, then you stretching it out. Like you pull the function upside down, not upside down, but like you stretch it vertically, okay? And then if you have that number smaller than 1, for example, like 1/3, or I don't know, like 2/5, something like that, it means that you're shrinking your graph vertically, okay? And if you have multiplication with a number, but for inside a function, it means you stretching. If your number is smaller than 1 and you shrinking the graph if your number is bigger than 1 horizontally, okay? And let's talk about what I mean by all of that, right? Okay, last objective of like this section, graphs of exponential functions. All right, so let's see, where should I begin with this? Okay, so this one is the name of the left picture, and this is the name of the right picture in there. If you ask me, do I have to remember these two like graphs, like all of these lists in here? The answer is no. Well, this is online class, right? So you can print it out and have it in front of you if you want to get ready for the tests or quizzes. But no, you don't have to memorize any of these, okay? If you remember something from these lists, that's cool. That's like awesome. But if you don't, that's fine, okay? So domain in here for the x-axis, as you can see, you can extend it on this side, and you can also extend the graph from the other side. So we have all x value in here. But for the range, for the y value, if you know this, there's nothing below the x-axis, right? Like we don't have anything below the x-axis. The graph is only on the top half of the y-axis. That means that the range in here has to be everything above 0 exclusively, okay? And for intercept, we have one y-intercept right here, which is 0, 1, and it's always decreasing from left to right. So if you go from left to right, you have this function decreasing, right? It's like going down, okay? The next two lines here, when we talk about limit, I'm gonna remind you guys these two lines, but for now, don't worry too much about it. continuous, it means that it keeps run on, right? It doesn't break out at any point on the function, on the curve, on the graph in there. And it's 1 to 1 because it passes the horizontal line test. At any time when you draw a horizontal line, it only touches the graph once. Okay? Like I said, you don't have to remember all the features in the list in here, but if you do, that's good. That's great. You are fitting for math major. That's a great news. And for the other functions, you can read this list, and it's just similar to what I explained for the first picture, okay? Okay, for my tips, to sketch a graph of exponent function, I always plot the y-intercept and another random convenient point, and make sure you identify the HR, the HA, or the horizontal asymptote. You guys gonna ask me what does it mean by horizontal asymptote? Asymptote is something that we learned from the derivative. I'm just like using this one as a tool for us to be like easier to sketch your graph. Let me do the very first example, and I'll tell you guys like what the horizontal asymptote means. Okay. So first of all, y-intercept. Y-intercept, it means that we let the x equal to 0 and then we solve for y, right? So if I let the x equal to 0, I'm gonna get 5 to the negative 0 plus 1, and I told you guys anything to the 0 is 1. So we have 1 plus 1, which is 2, right? And as a y-intercept, we have 0, comma 2. So the point here is right here. Okay, that's the first point, the very first part of ours. Second point, you can go random with it, okay? So let's do, I don't know, 1. If you input 5 to the negative 1 plus 1 into the calculator, you're gonna get 1.2 approximately. Like, is it a bad decimal, or is it like a cube decimal when you try? Oh, it's a solid 1.2. Okay, that's good. So that means that the point here is 1 comma 1.2, right? And where is it? It is right here, I think. Okay, there we go. And then as you can see, the look of the graph in here, let me take out some like pieces or some things in here. Okay, so as you can see, it can only look like this or like that, right? It has to be curvy, it cannot be lines, okay? We are done with the lines, okay? So make sure you don't connect them like this, okay? This is wrong. We don't talk about linear equation. We're talking about exponential equations or functions. So it has to look like this or like that, right? So whichever like makes sense to you, graph it that way, okay? So let me go back. Okay, so you have two options, either this one or that one, right? My instinct tell me that it's gonna look like this one. Why? Because it's easier for me to draw it that way. So I'm gonna draw it like this, okay? If you ask me why don't I go for that one, I'm gonna ask you, well, can you ask yourself to draw this picture, like how to connect these 2 points, but in this manner? I don't think so, to be honest. There's like no way to connect these 2 points in this manner, so that's why I have to go with the first option right there, okay? But it really depends on the positions of your 2 points, okay, in order to draw like a good image of your graph. Okay, so let me put back the line here. And a good feature of exponential function is that it always have like a bottom limit, okay? So for this graph in here and this graph in here, if you notice, it never actually touches or like crosses the x-axis, right? For none of these, like this is the x-axis, it never touches the x-axis. This is the x-axis. This one, it never touches on the x-axis, right? So there has to be something like that in this function for my function. How do I know that? Okay, for now, for just for this section, I'm gonna tell you a quick trick. Horizontal asymptote is whatever like free number you have like after the function, okay? And it's always looks like y equals to a number, and this number really depends on your graph, okay? So for my example, I have a 1 as a free number, so then my horizontal asymptote, it is y equals to 1, okay? And this tells me the limit. It tells me that if I draw like a line y equals to 1, let me put in dash. I'm trying my best to do like the dash, but it looks like dotted line for some weird reason. Okay, let me try again. So, okay, this is my line of y equals to 1. Okay, how do I draw it? First of all, I go to the y-axis because it tells me so, and then I go for the value of 1 right here, and then I draw a horizontal line. That's why it's called the horizontal asymptote, because it lines horizontally, okay? And my graph, the curve in here, the one that I just draw, let me put like the two arrows in here, it can never touches on the dash line, okay? So if you want to zoom it out, let me put in another like color. This is my graph, okay? Actually, here's the thing. Okay, let's not draw the graph first, okay? Just imagine you start fresh, okay? And let me draw this picture again, but in like a good order of things. First of all, I got my 2 points. I got the y-intercept, which is 0, 2. Second of all, I have the second point, which is 1 and 1.2 right here. Okay, and third of all, I'm going for the horizontal asymptote. So I'm gonna do, okay, the dash line at 1, y equals to 1. And make sure you label it too. This is y equals to 1. And then this is like, I don't know, 0, 2, and the other one, this is 1 and 1.2. Okay, and lastly, you connect the 2 point, make sure your line never touches the dash line, so it goes like the, okay, that's a bad one. Very, very bad one. So let me, okay, just imagine it touches the 2 points, okay? It's really hard to draw on an iPad. Okay, and some of you guys may ask me, how do I know where to start? Do I draw it like randomly? And I'm gonna say yes. You can have it drawn like that, or another people, they can have it drawn like this, or like another person, they can have it drawn like, I don't know, like this even. Like whatever you do, as long as your curve touches the 2 lines and it never touches on the dash line, then you cool, okay? And as for your part, you're gonna have this one in here, but just like a heads up, your part, it doesn't have the horizontal asymptote, okay? So when it doesn't have like a free number, it doesn't have any like big size number after the function, you're gonna have the horizontal asymptote as y equal to 0. So for your part, for your example, this one, make sure that your graph, your function, your curve, it never touches the x-axis, because y equal to 0, it is the x-axis, okay? And some of you guys may ask me, well, I have a -2 in here, so why my horizontal asymptote is not y equal to -2? And I'm gonna tell you, if you look at the size of -2 in here, this one is for the exponent, right? So this is not like the free number that I'm kind of like talking about. I'm talking about like big size free number, okay? So if you don't have like anything like in big size after the function, like in here, you have nothing, right? That means that you have y equal to 0 as your horizontal asymptote. And that means your graph never touches on the x-axis, okay? If you have any questions on this one, let me know, okay? Or simply, if you want to double check with like technology, you can draw this graph on Desmos. Most of you guys heard of it, I believe, or on GeoGebra, if you want to. Okay, and that's the end of this section. Thank you for your listening, and take care. Bye bye.